Okay, these are our first notes in our geometry unit of chapter 9. We're going to be talking about angles today. So we've got 4 different types of angles. We've got complementary, supplementary, vertical, and adjacent. Okay, so complementary angles. Okay, let's draw us a picture. Complementary angles add up to equal 90 degrees. Okay, so if I had, we're just going to leave it like that. Okay, so complementary angles have to equal 90 degrees. And a way you can remember this, there's 2 ways. So in complementary, we could take the C in complementary and we could make that like into a 9 for 90 degrees. Or you could think of complementary and corner both start with a C. So complementary and corner both start with a C, and then a corner makes a 90-degree angle. So there's a couple ways to remember that. So let's go in and let's talk about complementary angles. So if I open up this flap, 2 angles whose measures have a sum, we know that sum means to add. So when I add 2 angles together, they have a sum of 90 degrees. So if I add those 2 angles together and they equal 90 degrees, then they are considered complementary angles. Okay, so let's see. I've got this angle 55 and this angle 35. Well, if I added 55 plus 35, that does equal 90. So since these 2 angles add together to equal 90 degrees, or they have a sum of 90 degrees, that means that they're complementary. So angle, that's the symbol for angle. You're going to see this a lot in your geometry unit. So angle XWY. So XWY. XWY. Notice I go in order, X, W, Y. So this angle of 55 degrees and angle WYZ, so I'm sorry, YWZ, so YWZ, which they tell us is 35 degrees, since those add together to equal 90 degrees, they are considered complementary. And if you forget how to spell that, it's right there on the front. Complementary. So remember, complementary angles have a sum of 90 degrees. You can either remember that the C can turn into a 9 for 90, or complementary and corner both start with a C, and corners make a 90-degree angle. The next angle we're going to talk about is going to be a supplementary angle. So a supplementary angle. A supplementary angle is an angle who adds up to equal 180 degrees. So like my tricks I have for complementary, I have some for supplementary too. Okay, for supplementary, as you can see, this S, we could connect them and that makes an 8. So 8 for 180. So supplementary is 180 degrees. Or you can see that this line right here, this bottom, that is a straight line or a straight angle. So it makes a straight line. So supplementary and straight line both start with S. So complementary, corner, think of a corner, supplementary, straight line, okay? Or that turns into an 8, that turns into a 9, whatever works best for you. So let's go through and let's try it. 2 angles whose measures have a sum of 180 degrees are supplementary angles. All right, supplementary angles. So this says angle XWY. So angle XWY, which is 145 degrees. says right there. An angle YWZ, so YWZ, that's 35 degrees. If I add those together, I get 180. So since they add together, they have a sum of 180. That makes those two angles supplementary. Okay, it makes those two angles supplementary. So remember, supplementary makes a straight line. Both start with an S. And that needs to equal 180 degrees. Okay, so here's these two. Let's try them on our own. We need to find the angle measurement of x. So they want us to solve for x. Well, I know that two angles put together that make a corner needs to equal 90 degrees. So there's two ways that you can do this, and I'm going to kind of split this in half. The first way is to say, okay, well, I know that these two angles added together need to equal 90. So I know this one's already 68, so let's take the 68 away from the 90. That leaves us with 22. So that means that this angle right here needs to equal 22 degrees. So 2x should equal 22. Well, this is just a one-step equation that you know how to solve for. So we're going to cut it in half. We're going to isolate the variable. So the opposite of multiplying by 2 is dividing. We're going to divide both sides by 2. So x equals 11. 22 divided by 2 is 11. X equals 11. The second way to do this is to set up a two-step equation, which pre-AP I know you know how to do this. Core, go ahead and watch this and see if it makes sense to you. I know that these two angles added together have to equal 90. So that I know that 68 plus 2x, these two angles added together have to equal 90. Well, this is called a two-step equations because I'm going to have to do two things to solve for x. So the first step is to cut it in half. The second step is to isolate the variable. But in order to do that, I'm going to have to get rid of this addition or subtraction first. So I have an adding 68 or positive 68. So I'm going to subtract 68 from both sides. That leaves me with 2x on the left side, and 90 minus 68 is 22. Now I'm back down to my one-step equation. Cut it in half, divide both sides by 2, my 2's cancel, x equals 11. So you get the same answer either way. Pre-AP, this may be a little easier for you because that's what you're used to. Core, since this is new, it may not be the way you choose to do it. You may just choose to subtract that angle from 90 to figure out what you have left, and then you can set this angle equal to that. Up to you. So let's do the same thing for a supplementary or straight angle. Remember, supplementary angles have to equal 180 degrees. So we'll do the two ways. First way, I already know this is 114, so let's take that away from 108. Power from 8. That leaves me with 66 degrees. So that means that this angle should equal 66 degrees. So x minus 2 should equal 66 degrees. Well, let's solve our one-step equation. Opposite of subtracting 2 is adding. So x should equal 68. Okay, there's your first way. The second way is by using a two-step equation. So I know that 114 plus x minus 2 should equal 180. Well, this one is kind of like a two-step equation, but we're going to combine like terms. So I can combine 114 and minus 2. So 114 and minus 2, well, that's 112, plus x should equal 180. So that goes back to the combining like terms, which is from chapter 7. I can combine the numbers because they're the same. So 114 minus 2 is 112. So now I have a one-step equation. So I'm going to cut it in half, isolate the variable. That's a positive 112. So I'm going to subtract 112. And x equals 68. You get the same thing either way. So those are complementary and supplementary angles. Now let's talk about vertical and adjacent angles. So vertical and adjacent angles they look a little different. They don't add together to equal anything. We just have to figure out which is which. So a vertical angle, I'm going to come back to the front. Or no, I lied. I'm going to write it like this. So a vertical angle, that's how I like to write it. Vertical angle. Notice when I drew my picture, the tips of the V and the A touch. So vertical angles are going to kind of look like this. So if I open this up, two angles formed by intersecting lines. They are always, and this is, I'm sorry, you're going to have to like write over here, across from each other. So vertical angles are always across from each other, and they have the same angle measure. The same angle measure. So if you flip back and you look what we drew for vertical angles, okay, these are across from each other, vertical angles. Well, let's look at this. If I drew the V and the A in here, I have a vertical angle. These angles are across from each other. They make a V and an A, vertical angles, and they are the exact same angle measure. That's 35 and that's 35. So vertical angles are always the exact same. So this is saying that angle XYZ, so XYZ is blank to AYB. 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 So since they're vertical angles, they are equal to each other. So angle XYZ is equal to angle AYB. Vertical angles, they make a V and an A. Their points touch, they're across from each other, always equal the exact same thing. So if I look at this right here, the triad, we're going to find the angle measurement of x. We're going to solve for x. Well, this makes a vertical angle. It still makes a V and an A, a vertical angle. Maybe a little wider than we're used to, but you can still see it's like a stretched out V and A. They're across from each other, and they always have the exact same angle measure, so they're equal to each other. So that means 135 has to equal x plus 5. Well, this is just a one-step equation. Cut it in half. The opposite of adding 5 is subtracting 5. 5's cancel, so 130 equals x. Okay? So vertical angles make the V and the A. You may have to, move your paper so that you can see that's a V and an A. But they're across from each other, okay? And they're always equal, okay? They equal the exact same thing. The last angle we're going to talk about is an adjacent angle. Adjacent means next to. I don't have a fancy way for you to remember this like I do for all these. Just simply knowing what the word adjacent means will help you with this. So adjacent means next to. My neighbors are adjacent to me. So maybe I can put that. My neighbors are adjacent to me. So my neighbors are next to me. Maybe you can remember that. Neighbors and next to both start with an N. So adjacent means next to. Think of adjacent, you think of your neighbors are next to you. So adjacent angles are two angles that are side by side. Unlike vertical, they were across from each other. Adjacent angles are side by side, and they have a common vertex. So that's a new word for us. Vertex is just a point that they share. So the vertex, let's say ZYB, is where these two lines come together. So this line and this line come together at the point Y. So Y would be the vertex. So they share a common vertex and side. Okay? They are next to each other, like your neighbor. They're neighbors. Okay? Adjacent angles are neighbors. So let's pick some angles here. Let's pick this angle right here. So that is angle XYA. So angle XYA, XYA. And let's find an angle that is adjacent to that, or right next to it. So they have to share a common vertex or a common point, and they have to share a common side. So they have to have the same side. Well, if I look at this angle right here, okay, angle CYA, angle CYA, angle CYA shares the same vertex, okay, they both have a vertex at Y, and they share the same side. They both have the same line. This is the same side. So because they share a common vertex and the same side, they're neighbors, they're right next to each other, that makes them adjacent angles. Okay? So if I look over here and I wanted to find, let's just say, two examples of adjacent angles. Well, I need angles that are neighbors or next to each other. So here is angle 1. Angle 1. And a neighbor of angle 1 that shares the same side and a common vertex would be angle 2. Angle 1 and angle 2. You also could have picked angle 5 if you wanted to, because that's a neighbor on the other side. I just chose angle 2. Okay, what if I chose angle 4? What would be an adjacent angle to angle 4, or a neighbor of angle 4? Well, what about angle 3? Angle 3. Okay, you could also pick angle 5. That's also neighbors to angle 4. But those are adjacent angles. So adjacent angles are neighbors. They're right next to each other. They're neighbors. Vertical angles are across from each other. Okay? So these are your notes on the 4 different types of angles. This is the first notes. It's stop 1, pit stop A for chapter 9, angle relationships.